Hello guys, welcome back to our stream. It's our episode 8 and today I'll try to study it again, study with you. So uh, let's get right into it. So today I have decided to put I've decided to study for today our agenda. So the lesson topic that we're gonna be studying is about I want to study science. I mean, actually, never mind. I will study math. No, never mind. Science. We will study chemistry. So, I will study about stoichiometry for today. But first, let's go ahead and go with the Lewis acids and base and complex ions.
This is MSJ Chem. In this video, I'll be looking at the Lewis theory of acids and bases. Let's start with the definitions. A Lewis acid is a lone pair acceptor. A Lewis base is a lone pair donor. Here we have the reaction of NH3, which is ammonia, and BF3, which is boron trifluoride. As you can see, NH3 has a lone pair of electrons, and boron trifluoride has an incomplete octet, which means it only has 6 electrons in its valence shell. NH3 is a Lewis base because it's able to donate the lone pair of electrons to BF3, which is a Lewis acid. A coordinate covalent bond is formed between the acid and the base, which is shown by this arrow here. A coordinate covalent bond is formed when one species provides both the electrons in the bond. Transition metal ions, such as the copper 2+ ion in solution, are Lewis acids. Ligands, such as H2O, are Lewis bases. Here we have an example of a complex ion formed from a copper 2+ ion and 6 water molecules, which are known as ligands. The central metal ion, which is the copper 2+ ion, is acting as a Lewis acid by accepting these lone pairs of electrons from the water molecules. The water molecules are donating the lone pairs of electrons on the oxygen atom to the copper 2+ ion. Therefore, they are acting as Lewis bases. And as you can see, the arrows represent the coordinate covalent bonds formed between the ligands and the central metal ion. And finally, we look at nucleophiles and electrophiles. Nucleophiles are electron-rich species that donate a lone pair of electrons. They are Lewis bases. Here we have some examples of nucleophiles. We have the hydroxide ion, the chloride ion, and ammonia. Electrophiles are electron-deficient species that accept a lone pair of electrons. They are Lewis acids. And here we have some examples of electrophiles. We have boron trifluoride, the carbocation, and the copper 2+ ion.
Okay, so I didn't really get some good and useful insights because the video was kind of short. But what I'm getting from that video is that Lewis acid refers to the part of the atom in a bond where it's the one who gives something. So when so for ionic bonding, for example, the most basic one, sodium chloride, sodium only has one electron, while chlorine has seven. So in order to follow the octet rule, the sodium would give the his one electron to the chlorine, so it will become eight. And the reason why sodium will give because it takes less energy because it only has one. And after he gives that one electron, he gains a positive charge and a positive ion. That's what we call cation. And what I'm getting in the last video is that is the cation, and the one who gives is definitely the Lewis acid, while the one who gains electron is the donor, is the base. That's right. This isn't really helpful. Let's watch the organic chemistry tutor.
In this video, we're going to talk about Lewis acids and Lewis bases. A Lewis acid is basically an electron pair acceptor. A Lewis base is an electron pair donor. So,
Also, my concept
examples
was
of
the
electron pair
opposite. Okay.
acceptors are ions with positive charges, such as H+, Fe2+,
Oh
Al3+.
yeah, the one
These are
who
all Lewis
gives
acids. They can accept
is the
or
Lewis
pair
acid.
electrons. Lewis bases are electron pair
Lewis
donors.
bases are the one
Any type of
who
ion with
gains
negative
the
charge, like
electrons, so they get
chloride, chloride,
negative ionic
these are
charge.
Lewis bases. They have plenty of lone pair electrons to donate. Some other examples include hydroxide, iodide, water is a Lewis base. Water can act as a Lewis acid too, but it can behave as both. It can accept a pair of electrons, or it can donate a pair of electrons. Water is amphoteric. It can behave as an acid or as a base. Zinc chloride is another Lewis acid. BH3. All of these can accept a pair of electrons. FeBr3, AlCl3. These are some other Lewis acids. The methyl carbocation is a Lewis acid. A carb anion is a Lewis base. Ammonia is another Lewis base. And so as you can see, Lewis bases, they're basically nucleophiles. They're electron rich. And Lewis acids are electrophiles. They're electron poor. Now let's go over some reactions dealing with Lewis acids and Lewis bases. So consider the reaction between boron trifluoride and ammonia. Ammonia is a Lewis base. It can donate a pair of electrons. Bf3, that's a Lewis acid. The boron atom can accept a pair of electrons. So whenever you draw the curve arrows, it's always going to go from the Lewis base to the Lewis acid. And so the product of this reaction is going to look something like this. A covalent bond is produced. Nitrogen is going to have a positive formal charge, and boron is going to have a negative formal charge. So that's a typical Lewis acid Lewis base reaction. So let's work on some other examples. What's going to happen if we put FeCl3 and Cl- together?
Is there gonna be a
You're going to get
minus
FeCl4 minus. But let's
for
try it.
minus? Okay.
So FeCl3, like BF3, it has a trigonal planar shape, and this chloride has 4 lone pairs and a negative charge. And so it's going to attach itself to the Fe atom, and now you're going to get this. So now the iron atom has a negative formal charge. Now let's look at another example. Zinc chloride and H2O. Go ahead and predict the product of that reaction.
Wait. Zinc chloride and H2O. Wait, where's my ball pen? Ball pen. Come on, where's my pen? You know what? Let's use our good old paint. This is what we've been using the last streams, so we're gonna use it. So we have zinc. We have zinc, D, dichloride plus dihydrogen oxide. Okay, so I guess since the here the zinc, so we I want to go to the periodic table and look at their how many valence electrons they have. So we know that chlorine has 7, while zinc has oh zinc has 12. Okay, so I don't know how he get that. So, but basically Cl, that's the formula, and he got the H2O. So you have so it's gonna be like this, I guess. Cl, Cl, mm, maybe O, H. Is it correct? Let's see.
So let's draw it out. So I'm going to draw zinc chloride like this, and then we're going to react it with H2O. Oxygen has 2 lone pairs, and so the oxygen atom is going to attack the zinc atom. And we're going to have a trigonal planar shape around the zinc atom.
Well, we're right. We're right.
So now oxygen only has 1 lone pair, but now it has a positive charge. Zinc is now going to have a negative formal charge. And so that's going to be the product of that particular Lewis acid-base reaction. Whenever oxygen has 3 bonds, it typically bears a positive formal charge. And so
So
that
we're technically correct. We just need to indicate the negative, positive. Since zinc has how many? Zinc has four, three or four shells. The fourth, and it also belongs in the D block. The D block can accommodate 10, di ba? Like, it's a special case. Okay, it's fine.
that's going to be the product of that particular Lewis acid-base reaction. Whenever oxygen has three bonds, it typically bears a positive formal charge. And whenever you add a new bond to a metal, it usually carries a negative charge. Try this example.
So we try aluminum, and this is aluminum tribro triberyl hindi tribromide. Then we got a Br, then another Br, then another Br. Then we need to add this with a Br, which is negatively charged. So to do this, if we're gonna give, it's gonna turn positive, it's gonna turn negative, it's gonna be like that.
This
Is it good?
reaction will be reversible, and you're going to get this AlBr4 minus. So the bromide ion is going to attack the aluminum atom. And so you're going to get AlBr4.
Oh, I was right.
It has a tetrahedral molecular geometry, and the aluminum atom now carries the negative charge.
Yes,
And so
negative,
that's it.
then the bromide
That's
becomes positive.
the
Okay.
basics behind a Lewis acid-base reaction.
Okay. It's just the same with the or ionic bonding rules. So the one who gives will have positive charge, while the one who receives will have the negative. Okay, pretty understandable. I understood it. Yay. Okay, let's learn more. Oh,
Now
there's
let's look
more.
at another example. Zinc chloride and H2O. The
Oh, that
basics
was
here.
it. So we got he has 203 playlists. Let's learn all of them.
In this video, we're going to talk about organic chemistry. Now, this video is for those of you who are taking.
What is non-polar covalent bond? I'm actually curious about that.
In this lesson, we're going to talk about ionic bonds, covalent bonds, particularly polar covalent bonds and non-polar covalent bonds. So let's say if we have this bond, the bond between two hydrogen atoms.
Hydrogen
Would you
bond.
describe this bond as ionic, polar covalent, or non-polar covalent?
Polar
Anytime you have
covalent.
a bond between two atoms of the same element, it's always going to be a non-polar
Ay, joke lang.
covalent
Non-polar.
bond.
Non-polar.
Now, the reason why it's a covalent bond is because the electrons in this bond are shared equally due to the fact that we have the same atom, the same type of atom, and so therefore they have the same electronegativity, and so they pull on those electrons with an equal force. So because the electrons are shared equally in this molecule, it's going to be a non-polar covalent bond. Now here's another example for you. What about the carbon-oxygen bond? Would you describe it as ionic
That's
or covalent?
wait, so C carbon has 4 and oxygen has 6. So this is so 6. That's ionic, right?
Now, anytime you have a bond between two nonmetals, typically it's usually a covalent bond. So we need to determine if it's
Why is it a covalent bond? You need to follow the octet rule in covalent bond. Ay, never
polar
mind. You're right.
covalent bond or a non-polar covalent
No,
bond.
you're wrong.
And we need
Oh,
to know
wait,
the
you're right. Never mind.
electronegativity value.
Wait, kasi in carbon we have 4, right? So here, in oxygen we have 6. 2, 3, 4, 5, 6. If that's a covalent bond, to create to create the octet rule, we need to share each other so that both of them would be 8. So oxygen's already 8, but there's still 2 remaining. And that's, yeah, you're right. Never mind. Never mind. 2 and 8 is correct.
Values of these two elements. So here are some numbers that you want to be familiar with. Hydrogen has an electronegativity value of 2.1.
Big brain.
Boron is about, well, let me list out the elements: boron, carbon, nitrogen, oxygen, and fluorine. So boron's about 2.0. Carbon is 2.5. N is 3.0. O is 3.5. F is 4.0. And these values are based on the textbook I'm using. Some textbooks might have slightly different values, but you want to use the values based on the textbook you're using. So carbon has an electronegativity value of 2.5, and oxygen has a value of 3.5. If the electronegativity difference is 0.5 or more, then the bond is said to be polar.
Okay.
If
Polar
the
if it's 0.5 or
electronegativity
more.
difference is zero point
But
0.4
if
or
it's
less,
equal
then the bond
to
is said
or
to be polar.
lesser than 0.4, it's
So
nonpolar.
0.5 minus 2.5, that's 1. So therefore, we can say that the carbon-oxygen bond is a polar covalent bond. The
Yes.
electrons are being shared, but not equally. Now, because
Okay.
oxygen is more electronegative than carbon, it's going to have a partial negative charge. And carbon, because it's less electronegative than oxygen, it has a partial
No, it's
positive.
not 8. Really? How is it 8?
So
We
how can
just
we
did it.
indicate
It's supposed to be 2
the bond?
plus.
How can we show the dipole moment in this bond?
Fine, it's fine.
You need to draw an arrow pointing towards the more electronegative element. And so whenever you see a dipole moment
It's a
like this,
sword.
it tells you that this bond is a polar bond.
Okay, that's a polar bond. What about non-polar? Is it a knife?
Now, what about the bond between sodium and chlorine?
Ionic,
Would you
ionic.
describe it as ionic, polar
Ionic,
covalent, or
ionic,
non-polar
ionic,
covalent?
ionic, ionic. We just talked earlier. It's ionic,
Sodium
ionic.
is a metal, and
Yes,
chlorine
metal and
is a
non-metal.
nonmetal. And typically, when you have a metal mixed with a nonmetal, for the most
It's
part, it's
a
safe to
ionic.
say that it's going to be an ionic bond. Sodium chloride is made up of ions. In this substance, sodium has a positive charge, and chlorine has a
Has a
negative
negative
charge.
charge, but it
Positively
receives.
charged ions are known as cations, and
And negative
negatively
is an
charged ions
ion.
are known as anions. And so that's why we have an ionic bond. We know that opposite charges attract, and so there is an electrostatic force
Mm.
of attraction that keeps these ions held together, and that makes the ionic bond. So typically, whenever you have a metal mixed with a nonmetal, ionic interactions are usually created. Now, it's important to understand the difference between an ionic bond and a covalent bond. In a covalent bond, the electrons are shared. In an ionic bond, the electrons are
It's
transferred.
given or
So,
taken.
in a polar covalent bond, they're shared
How
unequally.
given
In a
or
non-polar covalent bond, the electrons are shared equally.
give and receive. I don't know.
Sodium has
Give and
11
take pala.
electrons, but it has one valence electron. Chlorine has 7 valence electrons.
Yes, now the Na
So
will
when you
give the
put
one
together
to the Cl. So it should be octet
here
rule and
an atom of
ionic bonding
chlorine
cell.
and sodium, it's going to give away its one valence electron to chlorine. And when it loses that electron, it acquires a positive charge.
Yes,
When
that's
chlorine
the Lewis
accepts it,
acid.
it's going to have 8 valence electrons. and so it's going to be negatively
Yes,
charged
that's the
since it
Lewis
gained
base, the
an extra
CL.
electron. So after this transfer of electrons, there's going to be an electrostatic force of attraction that holds these ions together. And so that makes up the ionic bond. Now let's talk about the hydrogen atoms that make up the H2 bond. Let's say if we have two individual atomic hydrogen particles,
That's up
both of which contain
non-polar
one
because,
neutron.
as you just said,
When
if
these
it's
two get
lower,
together,
the
they
difference
will each
in
give up their valence
electronegativity
electron
is equal
to
to or
form
lower than
a
zero point
covalent
0.4,
bond.
it's non-polar. Now, when you subtract the
And
hydrogen
so
to
the two
hydrogen, it's gonna
electrons
be 0.
represented by that bond
So
are shared
it's
equally
it's
among both
non-polar.
hydrogen atoms, and that's why it's a non-polar covalent bond. The electrons are shared. In an ionic bond, you had a transfer of electrons. Sodium gave up an electron, chlorine accepted it. But here, both hydrogen atoms contributed an electron to create this covalent bond. And so that's why it's not ionic, but it's covalent. You have a sharing of electrons as opposed to a transfer of electrons. Now let's go through some more examples. So what about the carbon-hydrogen bond? Would you describe it as ionic, polar covalent, or non-polar?
Hydrogen, helium. So
In carbon,
5, uh, there's 4. So in carbon, may 4. Hydrogen only has 1. So, kailangan, if we want hydrogen to be thingy, we can put 2 hydrogen na lang, and this will give them that. Yes, no, no, no. This will give, now both of them, three of them has 2, 2, 2. They fulfilled, so ionic.
has an electronegativity value of 2.5, and for hydrogen it's 2.1. So the electronegativity difference
Come on,
is
that's
zero point
that's
0.4,
nerdy stuff
which
right
means
there,
that
bro.
this
Never
bond
mind, you're right.
is nonpolar.
Okay.
Whenever you see a molecule that contains only carbon and hydrogen bonds, it's a nonpolar molecule. For
Okay.
example,
Good to know.
methane is nonpolar, it
Non-polar.
doesn't mix with water, or hexane, C6H12, that's a nonpolar molecule. They don't dissolve in polar substances like water or like alcohol.
Yes. Let's see.
Now, what about the carbon-carbon bond? Is it ionic or
That's
is it covalent?
a
Now, both substances have the same electronegativity value,
covalent.
so the
Covalent.
En difference is 0, which
Yeah.
means that it's nonpolar.
Non-polar. Non-polar
So
covalent.
anytime you have two of the same type of atoms that make up a
Mm.
bond, it's always going to be a nonpolar bond. The electrons will be shared equally. Now, what about the OH bond? What can we say?
Oxygen, hydrogen. Wait, oxygen has 6, hydrogen has 2. So, I know, hydrogen has 1. So, the lower maybe,
What can we
um,
say about it? Is it an ionic bond, a polar covalent bond, or a
polar
non-polar
covalent na lang
covalent bond?
siguro.
Well, let's start with the electronegativity values.
Ionic na lang, ionic,
For
ionic.
oxygen has an electronegativity of 3.5, and for hydrogen it's 2.1.
Joke lang, it's polar
So the
covalent.
electronegativity difference is 1.4. So this
Polar
bond
covalent.
is highly polar. Now, it's a special type of polar
Mm.
bond. Anytime you see hydrogen directly attached with nitrogen, oxygen, or fluorine, it's a special type of bond. Do you remember what it is? It's known as hydrogen bonding. These are very powerful intermolecular forces. Because of hydrogen bonding, water has a very high boiling point for um, being a molecule. Most molecules have low boiling points, but those with hydrogen bonds, they have relatively high boiling points. So we have a polar covalent bond. with a special case of hydrogen bonding. Now let's indicate the bond polarity. Because the oxygen is more electronegative, it's going to have the partial negative charge, and hydrogen is going to have the partial positive charge.
Yes.
So to indicate the dipole moment, we're going to draw the arrow
Oh yeah. So
towards the
it's
more
just
electronegative element.
a reverse
Now
sword.
let's consider one more example. What about the bond between lithium and fluorine? Would you say it's an ionic bond, a covalent bond, and
So I didn't.
if it's covalent, is it polar covalent or non-polar covalent?
I think it's kind
Lithium
of
is a metal,
ionic
fluorine
siya,
is a
ionic.
nonmetal. So automatically, just by identifying the type of element that we're dealing with, we know it's going to be an ionic bond. The electronegativity difference between lithium and fluorine is huge. But for the most part, if you have a metal and a nonmetal, it's safe to say that you have an ionic interaction. Lithium is a positively charged cation, and fluoride is a negatively charged anion.
Okay, I learned something. What's kekule? Kekule, kekule.
Consider this structure CH3, CH2,
Um, wait. Wait, be right back. Wait lang. Be right back. Um,
Stop again. 2 days ago, Cardinal their black switching for movement players in the new updates. Slowed down the rate into the black switch after shooting. But 2 days after the update, turns out it was just a bug yet again. And that's how Cardinal messed up again. 2 days ago, Cardinal their black switching for movement players in the new update, slowing down the rate that you can black switch after shooting.
Okay, guys, back. Bili na kayo, ang luto ng nanay ko ay galing sa puso. Napakasarap, ito ang paborito ko. Bili na kayo, wag niyo na 'tong sayangin. Minsan lang nagluluto ang nanay ko para itinda dahil gusto gusto niya kami lang yung masarapan kaya bumili kayo para masarapan din kayo. Oh my gosh! No. Ah, Alright, let's continue with our studies.
CH2 times 3, CH2 particular with a lone pair. It's attached to a CH2 group. So we have a carbon with 2 hydrogens, and then we have 3 CH2 groups. So that's going to be 3 carbons, all connected to each other,
Okay.
each with 2
Tapos,
hydrogen atoms.
yung,
And then we have another CH2 group with an OH at the end.
O tsaka H.
And so
Ganyan lang
this
pala
is the
mag-write.
calculate structure of this particular condensed structure.
Catholic structure. I see, I
Here's
see.
another example that you can work on. Draw the calculate structure of CH3, CH, Br, CH2, C, CH3 times 3. Take a minute and work on that example. So starting with the carbon on the left and working our way towards the right. That carbon has 3 hydrogen atoms attached to it.
Mm-hmm.
And then it's attached to a carbon atom, which has a hydrogen,
And a
and
bromine,
it has a bromine atom attached to
bromine.
it as well.
And next is another
And
carbon
after that, we have a
hydrogen,
CH2. So that's a carbon with 2 hydrogens, and that's attached to another carbon.
carbon,
And that carbon has 3 methyl
has
groups.
three CH3, CH3, CH3. Ah,
Now,
okay,
whenever
I
you
see,
see
I
a
see.
CH3 group, it's always at the end. It can never be in the middle.
Ah, okay. So yung CH3 at the end lang. Ah, I see, I see.
And this is a
Alright.
CH3 group as well.
Gets.
CH and CH2 groups, you can have that in the middle of the chain. But CH3 groups, they always tend to stick outside of the chain. They can't be in the middle. Now, here's another example: CH3, CH, CH3, CH2, CH, OH times 2. What about that example? It looks like we have a CH.
Alright. Well, okay. So my next agenda for today is to make a PowerPoint presentation that has a more effect. Gusto ko yung may more effect kasi it looks cool. And more, may pa bang mga teams na iba? How to make, how to make a more PowerPoint, more PPT, YouTube shorts. Jara, ja,
In
ja,
this video, I'll teach
ja.
you how I made this awesome presentation that went viral on TikTok. I'm using PowerPoint for Microsoft 365 as we'll be using the morph transition. Now, the first thing that we'll do is that we'll add a gradient field to our background. So just right click on the slide and click on Format Background.
If your PowerPoint is boring, try this. Search for a blueberry PNG on Google. Paste it into PowerPoint and resize. Make some copies and rotate them, arranging them to fill the screen. Create extra copies and fill the space below the slide. Select all the blueberries and group them. Insert another.
I'll check. So, for example, here we have, let's get rid of this. Get rid of this. Let's say I want this kind of circles. Can I just take joke lang. Yan. Tapos control B. Let's just place it anywhere. For example lang, place it anywhere. Tapos, below daw. There we have below. Alright. Next. Below. And but
Another blueberry and make it larger. Right-click it, choose Format Picture. Go to Artistic Effects and select Blur. Duplicate this blurred blueberry and rotate it slightly. Make more copies and arrange them like this. Select all the larger blueberries and group them. Duplicate slide. Move these two grouped blueberries upwards. Adjust your titles and text. Apply the morph transition to all slides. Follow for more PowerPoints.
so basically this duplicate it, then you move the group here. So when you transitions, you morph them. So it's like this. Yeah, it's like that. It's kind of okay. I think we can start with
Skills.
this.
If your PowerPoint is boring, try this. Search for a blueberry PNG on Google. Paste it into PowerPoint and resize. Make some copies.
What the heck? How do you do that? Ah, okay. Tapos, you combine it.
Instead, add a hexagon shape. Hold Control and drag to make a copy. Repeat until you cover half the slide. Select the shapes. Merge them together. Right-click Format and choose Picture Fill. Now format background and choose a gradient. I'm going for a yellow-orange gradient. Add your title, and now the magic starts. Duplicate the slide, grab the image from the bottom of the slide, release when your cursor is at the top of the slide, add your content on the second slide, add some design elements. I'm choosing hexagon shapes with no fill and a white outline. Spread them across the page. Open the Transition tab and choose Push, and there you have it, a slide to grab the audience's attention. Don't forget, stay creative. Don't make slides like this ever again. Try this instead.
Don't make slides like this.
Get make guys it this.
Change the background of a photo.
Okay lang. Thanks. I learned something.
Don't make boring PowerPoint slides like this. Let's try something fun and creative. Visit sketchfab.com. They have lots of really cool 3D models you can download for free. I'm going to use a 3D model of the Earth for this example. Download it in GLB format and insert into your PowerPoint. Make the Earth model bigger or smaller and turn it around to the angle you like. Right-click and go to Format Background. Pick a solid black color and click Apply to All. Duplicate the slide and spin the Earth model to show different parts of the world. Do the same steps for the other slides. Add a L shape. Fill it with white and set the transparency to 30%. Remove outline. Copy this shape and rotate it. Keep doing this until you make a frame that looks nice. Put the frame over the Earth model to point out the places. Last thing, choose all the slides and apply the morph transition. And you're all set. Follow us or more tutorials.
Yo, this is
Don't
cool.
make
What the
boring
heck?
PowerPoint slides like this. Let's try something fun and creative. Visit sketchfab.com. They have lots of really cool 3D models you can download for free. I'm going to use a 3D model of the Earth for this example. Download it in GLB format and insert into your PowerPoint. Make the Earth model bigger or smaller and turn it around to the angle you like. Right-click and go to Format Background. Pick a solid black color and click Apply to All. Duplicate the slide and spin the Earth model to show different parts of the world. Do the same steps for the other slides. Add a L shape. Fill it with white and set the transparency to 30%. Remove outline. Copy this shape and rotate it. Keep doing this until you make a frame that looks nice. Put the frame over the Earth model to point out the places. Don't make boring PowerPoint slides like this. Let's try something fun and creative.
Visit sketch file. Sketch file. So our thingy is sodium phosphate, I think. Sodium phosphate chemistry. Mm. Paste it in. Hmm. So it's asking me if I want to do something. This effect's cool. Wait, this is in fact cooler. Wait. I have an idea. What if we place it here? Not bad. Then I need another thing. So we need to find another image for this to work. Right, it's free. How is it gonna morph? Wait, let me see. Copy this and paste. It's just not good. Wait lang. I don't want to commit a crime. So,
Visit sketchfab.com.
Felice bota saca 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 sem nem ter preocupação. Elite bota saca 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 sem nem ter preocupação. Elite bota saca saca saca.
ikibag
Don't
or
make slides like this.
Hello everyone, this is Gamo Edits and welcome back for another YouTube video. In this tutorial, you will learn how to use the morph transition so you can create presentations like this and level up your next PowerPoint. In order for you to easily understand morph transition, let's start by understanding its basic function. Open your PowerPoint presentation and go to the slide where you want to create the morph transition. So I have here a blue circle shape. And then we will duplicate the slide, right click the slide and hit the duplicate slide option. On the duplicated slide, make any changes to the elements on that slide. You can reposition or resize your element. Let's try to move the circle from left to right. And now we will select both slides. Under the transition tab, we will select the morph transition. Now for the preview, let's see the preview for this. So, as you can see, it smoothly transitions from one position to another. Just make sure that you use the same element for both slides so that the transition appears seamless. Now let's attempt to change the circle shape to a triangle shape and determine whether it works as intended. Tab from slide not be visible. Circle to slide 2, which is a triangle, the morph transition will not be visible. However, we can still perform a morph transition between these two different shapes by using the appropriate naming scheme. To accomplish this, start the object name with 2 exclamation points and assign the same custom name to the two objects. You can alter the name of the shapes by navigating to the Home tab, then the Arrange and Selection pane. For the transition to function properly, the same name must be assigned to both objects in the Selection pane. We will apply the double exclamation format. We will copy this name from the circle shape and then paste it on the second slide for the triangle shape. We will just paste it here, which is basically the same name for the circle shape in the first slide. Now let's see if it worked this time. And as you can see, it is successful. We can now view the morph transition between two different shapes as long as they have the same naming scheme in the selection pane.
Yaks, ang ganda. Wow.
Now, to
Nice.
enable the triangle to exit, we will duplicate the second slide. To accomplish this, we will move the triangle to the right or beyond the slide under the slide 3. As you can see, the triangle in the slide 2 is in the right side of the slide, and the triangle in the third slide is outside the slide. So here is the final outcome, from circle in the slide 1 to triangle in slide 2, and the triangle will exit in the slide 3. So that is how the morph transition actually works in Microsoft PowerPoint. Now let's attempt to design an actual presentation with morph transition. I currently have a transparent picture of the Taj Mahal and a title text. To initiate the morph transition, we begin by duplicating the slide. We can now proceed to reposition and resize the elements in the second slides. As you can see, I move this Taj Mahal picture on the left part of the slide, and we will move this title text outside the slide in the second slide. Please observe the positioning of our photo in the first and second slides. Then we will apply the morph transition to all slides. As we apply the morph transition, these elements will blend together smoothly. The position of Taj Mahal moves from full scale in the first slide to half in the left part of the slide since we resize and reposition it. The morph transition follows the same principle as keyframing in other editing tools. Now I have added here another text to the second slide, and I will send it to the back as a layer. As you observe, the morph transition for the newly added text is just a simple fade transition. To make it more interesting, we will also apply the morph transition to this text. We will just copy this text and paste them on the previous slide, then send them to the back for layering. Next is to move this text downwards so that whenever we move from the first slide to the next, the direction of this text will come from below. So let's proceed with the tutorial by duplicating the second slide and then adjust the placement of the elements to achieve a morph or blending effect. Specifically, we will move the text or the history part upwards so that its direction matches the transition from the second to the third slide. And then as you can see, here's the preview for that. And then we will move this picture from left part of the slide to the right so that the movement will be from the left to the right. We will also add a picture, and these pictures are not yet included in the second slide. And as you notice, the transition for these
Okay,
pictures are just like the fade
I
transition,
get it now.
since these pictures were not included in the previous slides. And to apply morph, we will copy that elements and paste it in the previous slide or in the second slide. And then we will move this picture downwards so that the starting position for this will be from below. If we shift from second slide to the third slide, and then the text, we will move it in the left part. And here is the preview.
Whoa, this is
Now
cool.
let's try to adjust the
PowerPoint.
layering for this Taj Mahal for more seamless result, and that's perfect. We can also resize these pictures or rotate it for more dynamic effect for the morph transition. And here's the preview. Keep in mind that morph transition will help you make smooth animations, transitions, and object movements across the slides in your presentation. Now, let's try to duplicate the third slide and reposition our elements once again. We can delete this text box, the history part, since these texts are not involved in the third slide. And this lover's tomb text, we can move this upwards. And then for the time for the exit for this picture, we will rotate it and move it outside the slide. And now we can see the preview or the exit for the lover's tomb text and for the pictures. And now let's try to reposition and resize this Taj Mahal PNG image once again. And we will move this in this part, resize the image, and let's try to add this text, the inside Taj Mahal. So now let's copy that inside Taj Mahal text in the previous slide for the entrance morph effect. As you can see, the text came from the left side of the slide. So we can also create a carousel effect with morph transition for images in Microsoft PowerPoint by following these steps. Insert the images you want to use in your PowerPoint presentation and arrange them in order you want them to appear in the carousel. So I will add this image placeholder and then change the shape into a rounded corners. So we will now add the picture inside the image placeholder. Let's select this picture of Taj Mahal inside. So here it is. Now you can place or adjust the position of this image based on your likings. And let's try to copy that images and resize it, make it smaller. So we are doing this for the carousel effect. And let's try to copy this once again and paste it. And now we will change this picture, other pictures for our carousel effect. Let's try this another image for Taj Mahal inside. And for the last image, so let me just remove this, and now here are the pictures we're going to use for the carousel effect. And for the smaller images, I will add this grayish effect, duplicate the slide, and then replace the first image with the second image in the carousel. So we will just remove first these images and this text since we don't need them anymore. And now we will adjust the placement of the image and the filter as well. So we will move the first image upwards and the second picture upwards as well, and then we will change the size of that second picture with the size we just used for the first picture in the previous slide. Your carousel should look like this right now, and we'll just adjust. This time we will remove the grayish effect for the second image and apply the grayish effect on the first image. Now let's see the preview so far for this carousel effect. As you notice, the first image moved upwards and then the second image. And now we will just repeat the process until we reach the last image.
I get it, I get it.
Hello everyone, this is Gamo Edits and welcome back for another YouTube video. In this tutorial, you will learn how to use the morph transition so you can create presentations like this and level up your next PowerPoint. In order for
Okay. Well, this is
you to
kind of
easily
easy.
understand morph transition,
Chemistry. Um, it's your molarity formula. or the force. I want a background right now, like cool background. I need to just clarify our element though. What element did we use? Sodium phosphate, right? Is that right? Tagal? Where is it? This. Now we've got sodium phosphate and A3PO4. Sodium phosphate uses emulsifiers, in-process cheats, thickening agents, leavening agents for baked goods, control pH, laxative, dietary supplement, our electrolyte replacement purposes. Right, so ay, yung background maganda. Wag naman eto. I'm in love with the concept. Mm, mm, yung concept. Oh, this is cool. Wait. I want this. Wait, what is it? Why is this thing? Bro, this ugly. Now that's mid. This is better. Where is it? This is so much better. This is so much better. And it still seems mid, wait lang. Mid. That's what we've got.
In today's tutorial, we're learning how to make this nice opening slide in PowerPoint where the title and subtitle appear from a certain object or from behind an object in your picture. And for the first part of the tutorial, we're going to make the
Still on a chemistry background. This looks like midness, bro. Oh, I like this.
If no one can read the text in your slides, do this. Copy-paste the image and put it in the same position. Right-click on it, then Format Picture. From the Effects panel,
Oh, I want this. Yes. Yan. LT, LT. LT, LT. Lap trip. Ha? Then? No?
click on Artistic Effects. Select the Blur effect. Then increase the radius to 80. Click on the image panel and decrease the brightness to -20. Click on Crop and move this handle to the left. Finally, bring your texts back to the front and you're done. Save this video for later.
We're gonna make the hello. Oh, boys do. Oh, no. Okay. Oh my days, bro. Oh, um, no. Oh, shoot, shucks. To put I am here. So, palakihan natin. No. Oh. Look. Let me cook. Sa cameo. Try ko sa cameo. Huwag na mag-cameo.
In today's tutorial, we're learning how to make this nice opening.
Hello everyone, this is and then for the time for the morph effect of PowerPoint, and then the corner, let's select and arrange of the slide. So
What the freak? What the heck? Roar.
we can also create a carousel effect with morph transition for images in Microsoft. We can the left effect, as you can see, transition came from the left side of the slide.
Layout. What the heck is layout? I'm streaming. I'm gonna end na. I'm gonna end my stream.